Hello class. This lesson we're going to learn how to write proofs of known geometry facts. So by known geometry facts I mean things like the measures of the interior angles of a triangle always sum to 180 degrees. Something that we've just taken for granted up to this point. We're going to prove it. And so we've been using the words proof and theorem lately. There's a difference. Proof is a series of steps that all follow from things that we already know are true or we accept to be true. Whereas a theorem is a statement that we can back up with a proof. So for example, a theorem, like we have the interior angles of a triangle, their measures sum to 180 degrees. That's a theorem when we're going to back it up with a proof in this lesson. So first thing we're going to prove is we want to show that corresponding angles are congruent. And the only tools they're giving to us right now are vertical angles are congruent and alternate interior angles are congruent when the lines are parallel. And so they're telling us that these lines are parallel. And we want to end with x equals w. Notice we have degree symbols here, so we can use that short notation, just use the variables. And so what do we know about w and z? So we want w in this somewhere. Well, we know w equals z because those are pairs of vertical, it's a pair of vertical angles. And we want x in here instead of z. So how are x and z related? Well, you know those are alternate interior angles, and the lines are parallel, so their measures are equal. And now all I have to do is substitution. So instead of z, you're going to put an x in there. So now we have that third tool that we can use, and we're going to use them to show that the same side interior angles are supplementary. Another tool we have that they're giving to us is that linear pairs are supplementary, so they add up to 180 degrees. So in this case, they have a given statement. And that means it's something that they're telling you is true in this particular problem. And you usually start off your proof with what's given to you. And we know we want to end with what we want to prove. So I want to show that BGH plus the measure of DHG, those two angles, their measures sum to 180 degrees. So how do we know the first statement is true? Well, they tell us it's true. So that's just given. And we want to get BGH in this problem somehow. And we also want to get 180 degrees involved with it. So what can we say about BGH and some other angle that gives us 180 degrees? Well, here's more than one possibility. We went with here that the measure of angle BGH plus the measure of angle AGH, they sum to 180 degrees. Why is that? They're a linear pair, right? They form a line. And we want to get rid of that AGH somehow. We want to replace it with DHG. Well, let's see. Here is AGH and here's DHG. How are those two angles related? Well, we know their measures are equal because we have alternate interior angles. And so now we just substitute, and we have our what we want to prove. And so now we have another tool that we can use. Now we know the interior angles on the same side are supplementary. So now we're going to prove this one. We want to show that the sum of the angles and the sum of the measures of the angles in any triangle gives us 180 degrees. And so to do that, we're going to have to draw an auxiliary line. So we're going to call this line JK, and it's going to be parallel to side BC. Could have picked any side, but let's stick with BC. And now we labeled each of the important angles in this problem. And so based on what it says that we want to show, what statement should we end with? So we want to show that the three interior angles, their measures sum to 180 degrees. So which ones are interior? We have A, B, and C. So A plus B plus C equals 180 is what we want to show. Okay, so we want to get 180 degrees involved in this problem somehow. Where can we get 180 degrees from without, going back to saying, oh, well, we know the triangle interior angle is sum to 180, because that's what we're trying to prove, so we can't use that. Where else could we get a 180 degrees from? Well, we have this line JK, and what we know about the angle measure, a straight angle, 180 degrees. So we know if we add up D, A, and E, that gives us 180. So angles on a line sum to 180 degrees. Okay, so looks like we're on the right track, but we want to keep A in there. A is okay, but we want to replace D and E with B and C somehow. So how can we do that? So how is D related to B? Well, these lines are parallel, so those are alternate interior angles. So their measures must be equal. And the same goes for E and C. And so now we got to do a substitute, and we have what we wanted to prove. So now we know definitively that the sum of the measures of the interior angles in any triangle is always 180 degrees. So here's a whole bunch of tools we have so far. Keep them in the back of your head. And there's an ancient Greek called Aristophanes, and he calculated the circumference of the Earth, approximately, but really, really close, by using the properties that we've talked about in this lesson, particularly alternate interior angles. So there's another video posted with this homework. I'd like you to take a chance to watch it. It's really, I found it quite interesting, and you're going to learn a little bit more about the history of mathematics. So now here we have a statement, and they don't give us a whole lot to work with. We want to show that if two lines are perpendicular to the same line, they're parallel to each other. So it seems like something that should be true. So let's draw a picture that shows that. So I want you to sketch a picture that demonstrates this, and then compare your picture with mine. So here's my picture. Make sure you label all your important points. So now think about what it says in the problem, what we want to fill in based on our diagram for given and prove. Well, we're given that two lines are perpendicular to the same line. And one way we can write that is by saying, well, we can use segments as well, because every segment's part of a line. We're saying segment AB is perpendicular to segment EF, and segment CD is perpendicular to segment EF as well. So that is satisfying this first part, the supposition. What do we want to show now? We want to show that they're parallel to each other. So what do we want to show is parallel here? We want to show AB is parallel to CD. Okay. So let's start with our given. Oops, that's not what we're given. All right, there's our conclusion. And yeah, the way they formatted it in this one, they just said this given was part of the problem. So how do we get these statements? We're saying that the measure of angle AGH is 90, and so is the measure of angle CHF. How do we know that? Well, they're perpendicular lines. That's from our given. So really, you might want to, what I would do, I should have modified this, I'm sorry. I would have put this given as my first step. And then from that follows the second line. All right, so from there, let's see, we want to get AB parallel to CD. We have these angles are both 90. Well, if they're both 90, what can we say about each angle measure? They're equal. And that's just substitution. And so now, why are these lines parallel? Well, we know that this angle is congruent to this angle over here. So those are corresponding angles. And when corresponding angles are congruent, the lines are parallel. So notice how now we kind of use this backwards. Before we were saying that when lines are parallel, the corresponding angles are congruent. And now we took that and turned it around. And that is called the converse. So each of these statements, we're saying here two lines are parallel and cut by transversal, then the alternate interior angles are congruent. The converse of that is when you switch the order. So if we say that if two lines are cut by transversal and the alternate interior angles are congruent, then they're parallel. And that's true for these three different scenarios. So we would use the first one when we want to know something about angles. We want to show angles are congruent or supplementary. And we would use the converse when we want to go about showing that lines are parallel. So there is a distinction there. They're related statements, but they really are different. And here's another example. Here we have x equals y. We want to prove that AB is parallel to EF. So that's what we want to end with. And what do we have to work with here? Well, they told us x equals y. How do we know that? It's given to us. And so how does that give us that segment AB is parallel to segment EF? Well, those are corresponding angles. And we just learned that when the corresponding angles are congruent, then the lines are parallel. Let's say measure. It's a typo. Measure. All right, that was a little bit better. Okay, so in this lesson, we learned how to write proofs of known geometry facts. Thanks for watching this video.